Welcome back to the show, everyone. I'm Dr. Khan, and I am fired up today because we're diving into one of the most brilliant safety features of the human body. Have you ever wondered why, when someone has a slipped disc in their neck, they might have a weak arm, but they can usually still move it? It's not luck, it's engineering. We're talking about the segmental innervation of muscles.
Exactly, Dr. Khan. While it might seem like a chaotic web of nerves at first glance, the way our spinal nerves distribute to skeletal muscles is incredibly organized. For the boards, you need to understand that most skeletal muscles don't just rely on one single spinal nerve. They receive fibers from multiple segments of the spinal cord.
Think of it like the power grid for a high-security building. If the building only had one power line coming in from the street and a transformer blew, the whole place goes dark, total blackout. But our muscles, they have 3 or 4 different power lines coming from different floors of the spinal cord. If one line goes down, the lights stay on. They might be a bit dimmer, sure, but you aren't left in the dark. Dr. Sarah, how does that look on paper for the students?
On paper, we call this segmental innervation. Most muscles are innervated by 2, 3, or even 4 spinal nerves. This happens because of the plexuses, like the brachial plexus for the arm or the lumbosacral plexus for the leg. In these plexuses, the anterior rami of different spinal nerves join together, trade fibers, and then branch out again. So a single peripheral nerve, like the radial nerve, actually carries axons from multiple spinal cord levels, specifically C5 through T1.
And that is exactly why this matters clinically. If I have a patient come in with a traumatic injury at the C5 level, his deltoid muscle, which gets its juice from C5 and C6, isn't going to be completely paralyzed. It will be weak, which we call paresis, but it won't be plegic or totally dead. The C6 fibers are still there doing the heavy lifting. It's the body's built-in redundancy system.
That's a high-yield distinction for exams. Total paralysis of a muscle usually requires a lesion of several spinal nerves or several segments of the spinal cord. If you see a question where only one root is damaged and the muscle is completely non-functional, you should be looking for a different diagnosis. But Dr. Khan, we can't talk about these segments without talking about how we test them in the clinic.
Oh, the reflexes. This is my favorite part of a physical exam. It's like being a detective with a rubber hammer. When we tap a tendon, we are checking the integrity of specific spinal segments. If I hit the biceps tendon, I'm looking at C5 and C6. If I hit the triceps, I'm looking at C6, C7, and C8. Sarah, which ones are the big must-knows for the STEP exams?
You absolutely have to memorize these 5. For the upper limb, the biceps reflex is C5, C6, and the triceps is C7, C8. For the lower limb, the patella reflex, or knee jerk, is L2, L4, and the Achilles reflex, the ankle jerk, is S1, S2. I've even heard students say that their doctor of choice always starts with the patella reflex because it's so reliable for checking the lumbar spine.
I love that. And why does this matter clinically? Because if I tap that patellar tendon and get absolutely nothing, a flaccid response, I know that the reflex arc has been interrupted. It could be the sensory side, the motor side, or the spinal segment itself. It tells me exactly where to start looking with my imaging.
And remember, we also have superficial reflexes. Don't forget the abdominal reflexes. Stroking the skin of the abdomen tests T6 through T12. These are all part of the same segmental map that helps us localize a lesion without even needing an MRI yet.
It's all about the motor unit too, right? One single motor neuron plus all the muscle fibers it controls. In big muscles like the gluteus maximus, one neuron might talk to hundreds of fibers because we just need raw power. But in the tiny muscles of the hand, one neuron might only control 5 or 10 fibers because we need precision. Either way, those neurons are coming from those specific spinal levels we just mentioned.
Precision is key. If a student understands that the anterior horn cells in the spinal cord are the engines for these motor units, they can predict what happens in diseases like poliomyelitis, where those specific cells are attacked. If the L3 motor neurons are destroyed, the muscles they contribute to will show specific weakness, but they won't necessarily be gone if L2 and L4 are still intact.
Exactly. It's like a choir. If the tenor stops singing, the song sounds different and maybe a bit thinner, but the melody continues because the baritones and sopranos are still on the stage. Segmental innervation is the choir of the muscular system.
Beautifully put. So to recap the high-yield facts, most muscles are innervated by multiple spinal segments, typically 2 to 4. This distribution happens through plexuses. This protects us from total paralysis from single-level injuries. And finally, we use tendon reflexes, like C5, C6 for the biceps and L2, L4 for the knee, to clinically test if those specific wires are still plugged in.
Perfect summary. The main takeaway? The body is built for survival. Redundancy isn't a mistake. It's a masterpiece of clinical engineering. If you understand the map, you can find the problem. Thanks for joining us, everyone.